Alright guys, today's goal, the learner will understand and perform operations with complex numbers. Okay? The square root of a negative number. If r is a positive real number, then the square root of negative r is I squared r. So if you look at square root of negative 3, it's I square root 3. By property 1, it follows that I times the square root of r squared equals negative r. So what that's telling us is I squared is equal to negative 1. Because if I is equal to the square root of negative 1 and I square both sides, it just gets rid of the square root, so it's negative 1. Okay? So solve the equation. Take the square root of both sides. Don't forget this. Plus or minus square root of negative 13, it means I times the square root of 13. So subtract the 11. X squared is negative 8. Square root. So I get plus or minus I times the square root of 8. But you have to ask, can I simplify this at all? And the answer is yes, because I can make square root of 8 plus or minus I times the square root of 4 times the square root of 2. But what's the square root of 4? 2. So I get plus or minus 2I square root of 2. Okay? So here, subtract the 33 from both sides. You get 5x squared equals negative 30. Divide both sides by 5. X squared equals negative 6. Square root. X equals plus or minus I times the square root of 6. And there's nothing you can simplify square root of 6 by. So we're done. So it's really not different than what we solved before. It's just if they're square root of a negative, you have to make it imaginary because it's a complex number. Okay? Alright, so here's a lot of things we need to know. Okay? Complex numbers. A complex number written in standard form is a number a plus bi, where a and b are real numbers. The number a is a real part of the complex number, and the number bi is the imaginary part. If b cannot equal 0, then a plus bi is an imaginary number. If a equals 0 and b cannot equal 0, then a plus bi is a pure imaginary number, meaning only the imaginary number is there. The diagram shows how different types of a complex numbers are related. Two complex numbers, a plus bi and c plus di, are equal if and only if a equals c and b equals d. Okay? So they're only equal if they're the exact same imaginary number, guys. For example, if x plus yi equals 5 minus 3i, then x equals 5 and y equals negative 3. Alright, sum and differences. What this is saying, to add two complex numbers, you add the real numbers together and the imaginary numbers together. Okay? We'll do some examples later. Now, remember yesterday we learned conjugates. So if we would have had something like this, you'd have to multiply the top and bottom by 9 plus the square root of 7. So, because that's minus. So, here, a complex conjugate, if I have 3 minus 2i, the complex conjugate is 3 plus 2i. And we'll go over it. We'll see when we use that as well. Now, let's look over here. Okay. Notice how this starts at I to the 5th. Okay. So what we need to think about here. We know that I to the 1st equals I, and we know that I squared equals negative 1. Well, I to the 3rd, well, that's I squared times I, so that's negative I. And then I to the 4th is I squared times I squared, so that's negative 1 times negative 1, so that's positive 1. So we have I to the 1st is I squared is negative 1, I to the 3rd is negative I, and I to the 4th is positive 1. After that, everything repeats. So, see how here, they have I to the 5th, they did 5 divided by 4, remainder of 1, so it's exactly like I to the 1st. So what does that equal? I. Six divided by 4 has a remainder of 2. So what does that equal? Negative 1. Remainder of 3, that equals negative I, because I to the 3rd. I to the 0, well, anything to the 0 is 1. That's why I to the 4th is also, because you look at the remainder. And then they repeat. So it's I, or negative 1, negative I, positive 1. Okay, so you always have to look at the remainder. So let's take a look at some here. If I did 27 divided by 4, so if we think back to this, because that's I to the 27th, goes into it 6 times with a remainder of 3, so it's like I to the 3rd, so the answer to this, negative I. I to the 99th, well, 4 goes into 99 24 times. Also with the remainder of 3, so it's negative I. I to the 88th, that goes into it 22 times, a remainder of 0, so it's 1. Okay? So hopefully we're starting to see the pattern here. So write the expression of complex number in standard form. So we need to get them all A plus B I. So when it's a plus, you don't have to worry about it. So it's 9 plus negative 6, 3. Negative I plus 7i plus 6i. Now, when it's a minus, though, distribute that negative. So you get 3 plus 7. I minus 8 plus 2i. Now combine like terms. What's 3 minus 8? Negative 5. 7 plus 2, 9i. So go ahead and press pause. Take a minute. Try to do this last one on your own. Okay. Hopefully you did. The first thing I would have done is distribute the negative. So I would have got negative 4 minus 1 minus I minus 5 minus 9i. Negative 4 minus 1, negative 5 minus 5, negative 10 minus 10i. Okay. So just add the real numbers together. Good. Add the imaginary numbers together. Good. So write the expression as a complex number in standard form. So same thing. So here we have to distribute. So I get 9i minus I squared. But what do we know I squared equals? Negative 1. So I get 9i minus negative 1 So that would be 9i plus 1, but it's a plus bi. So you got to do 1 plus 9i. Okay? So this next one, 3 times 5, 15. 3 times I, negative 3i. I times 5, plus 5i, minus I squared. So I get 15 plus 2i plus 1. Because I squared is negative 1 times a negative becomes a positive there. So I get 16 plus 2i. Now remember, yesterday we learned about those conjugates. Well, this time we have a complex conjugate. So, three plus 2i. 3 plus 2i. Now I'm going to do this the long way, but watch what happens. So we have to multiply the whole top and the whole bottom. So you get 15 plus 10i plus 6i plus 4i squared. Now look at the bottom here. You get 9 minus 6i plus 6i minus 4i squared. Well, if we look at the top, I have 15 plus 16i minus 4, because I squared is negative 1. The bottom I have 9 plus 4. Because I squared is negative 1, so it changes to plus 4 instead of minus 4. Okay? So I have 11 plus 16i over 13. Now, this is what we have to remember to do every time. Separate. That is now in standard form. You have to separate the fraction. Okay? All right. So, graphing. Go ahead, press pause, look through the example, and try to graph these. Okay? So hopefully you did. So it's real number, comma, so how many imaginaries do we have? Negative 1. So 1, 2, 3, 4, negative 1. This would be graphing the point 2, comma 5. 1, 2, 1, 2, 3, 4, so it'd be up here. Didn't make the graph big enough. This would be 0, comma 4, because there was no real. So 1, 2, 3, 4. Okay? So now absolute value of those. So it says z equals a plus bi. So find the absolute value of z. So if I'm finding the absolute value of this, a equals 3, b equals negative 4, plug it into this equation. So the absolute value of z equals 3 squared plus negative 4 squared. So I get 9 plus 16. What's the square root of 25? 5. Now let's say you got something like this, square root of 32. Don't forget to simplify this. By that I mean exact answer. I can change that to square root of 16, square root of 2, which would be 4 square root of 2. Okay? So, there we go with complex numbers. And be ready to work on these tomorrow.